All right, so today we're going to learn about function notation, which is actually not learning math differently. It's just a different way of writing math. So the math that we're going to be doing is math that you've done before, but you're going to see it written in a different way. And it's not actually meant to confuse you. I was really frustrated when I was your age trying to figure out, why would they make things so difficult? But actually, I learned later on that actually this form of writing things actually makes certain things easier, but it does take a little bit of practice to get used to this way of writing it. So here we go. Veterinarians have used the rule that 1 year of a dog's life is equivalent to 7 years of human life. So we started a table, and we can see here that 1 year, 7, which means 2 is going to be 14. Can you fill out the rest of this table to figure out if a dog was 3, 4, and 5, what would it be its equivalent age in human years? Okay, so what if it was a 6-year-old dog? What would its equivalent human age be? And I get 42 years old. Now, I'm going to ask you to explain in your own way, how would you find the equivalent human age of a dog that is 10 years old? Now, you might have just kept adding 7 to that, but I hope that in your explanation, you had something to say that you basically could take the dog's age, which was 10, and simply multiply that by 7 to get to 70. I hope you gave some kind of explanation like that. And now that we've thought about it that way, well, if the dog was 10 years old, we would do 10 times 7. What if it was X years old? In part D, what is the equivalent human age? So just like 7 times 10 gave us 70 years old, for a dog that's X years old, it's 7 times X, or 7X years old. Okay, so that's using some algebra here. Now, instead of writing all this out in words, we can use a notation that's called function notation. The way to write for one of the previous problems, the previous problem that we just had, is f of x equals 7x. Now, this is actually really important to look at here. This part here, this side is pronounced f of x, which means a function of x. This is not f times x. You guys have always seen parentheses as multiplication. In function notation, it doesn't mean that. It means a function of x, and we'll get to the use of that in a minute here. But the key is that no matter what x is, in this case here, we're going to take that x and multiply it by 7. So whatever we have, the x is our input. We're going to input the dog's age, and then we're going to multiply it by 7 to get its equivalent human age. That's what that function here is going to tell us here. Okay, so in order to find the equivalent human age of dogs, what do you have to know about a particular dog? We have to know its age. And where is that in the function? We know that in this case here, we start off with the dog's age was X years old. Where is that in the function? It is right here that X is the dog's age. So we can say that is the X. How do you read the left side of the equation? So this part of here, how do you say that? We say f of x. F of x. Or we could say function of x. All right. Does the f of x mean f times x? No. F of x does not mean f times x. It's something very different. What does the x represent? Again, going back to B where we just answered that, what is x? It was the age. So we know that is the age of the dog in dog years. So if the dog is 11 years old, how should we write the function to find the equivalent number of human years? How we write this is really important. I don't want just the answer here. You guys know how to do that. What we're learning right now is how to use function notation. So I start off rewriting the function f of x equals 7x in there. All right, now, but instead of x, x was the dog's age, but this time we actually know the dog's age, and the dog's age is 11. Remember, x is the dog's age, but in this case, 11 is the dog's age. So we're going to replace every single x with an 11. So f of 11 is equal to 7, and instead of times x, we're going to say 7 times 11. To simplify this on the next step, all right, I'll go ahead and write it down here. We're going to say f of 11. The left-hand side, once we leave that, we never change that. We're not going to multiply or anything. That's just f of 11. That's what we're actually trying to find, the function of 11. And on the right-hand side, 7 times 11 is 77. So we have an input. We put in the 11 into the x, and we put it into that x as well. And then we get an output, which is what happens when we multiply it by 7. 7 times 11 gives us an output of 77. And what that gave us was 77 human years is what it was equivalent to. So a quick review here. This is really important here that we understand what we just did. We know the x is our input, and we know we're putting in the input specifically of 11. We put it in for the x on the left, and we put it in for the x on the right. Okay, we never simplify this left side anymore. It stays f of 11. That's what we're actually trying to find. We found f of 11 by multiplying 7 times 11, and we got 77 human years. So the input is in the answer, and the output is in the answer. So we know that f of 11 of that input gives us that output. Okay, and that's a really nice way of writing it so that we can see what goes in and what goes out in the same equation here at the end. Okay. So in this particular function, f of x equals 7x, what is the rule? This is a kind of a complicated, what does he mean? What is the rule? Well, the rule is, what am I doing to x every time that I put it into this equation? Well, I'm multiplying it by 7. Okay, so that is the rule, multiply by 7. That's the rule of what we're doing to this particular numbers that go in there. This function is multiplying everything we put into it by 7. Okay, so let's look at some other functions here. On number 4 here, we have a function that takes the number, the value, and it doubles it, and then it adds another 1 to it. So that's what this function does. No matter what number we put in for x, it's going to double it and add 1 to it. All right, if we want to find f of minus 3, that means that we're going to put our input here is going to be negative 3. I start off always by rewriting the function itself. So my function was f of x equals to 2x plus 1. All right, and then I want to find not f of x, I want to find f of minus 3. And it's really important that I line that up. I'm going to put f of minus 3 right underneath the f of x. All right, so what I've done is I have put in a negative 3 in for that x. Well, remember, I have to do that, put it in for every x. So for this x here, I'm also going to put in a negative 3 and then add 1 to that. Okay, remember that I do not change the left-hand side. So my left-hand side is always going to stay like that, f of minus 3. After all, I'm trying to find f of minus 3. So once I simplify the right side, I'm done. 2 times negative 3 is negative 6 plus 1. I'm running out of room here, so I'm going to go a little bit farther to the right. So I get f of minus 3 is equal to minus 6 plus 1, which is negative 5. And there is my answer. F of 3 equals to negative 5. They asked me to find f of minus 3, and there I am telling them f of minus 3 is negative 5. I have my input, negative 3, and I have my output, negative 5, all in the answer there. Very clear. And that's one of the great things about function notation. The answer actually tells me not just what I'm getting out, but it also tells me what I'm putting in to that. Okay, see if you can do for number 5 and number 6. There's two different functions there. See if you can find f of 2. Actually, go ahead and do number 5 first. See if you can find f of 2 if f of x equals x minus 4. All right, so there we go. We got f of 2 should equal to negative 2 here. I kind of cheated a little bit here. I just used the, instead of rewriting the function again, I just used the part that was already in there right above it. And right under there, I lined it up nicely, f of 2, which is going in for the x. This 2 is going in for this x. Then I just have to simplify the right-hand side. 2 minus 4 gives me negative 2. Okay, go ahead and try that with 6 as well. All right, this time I plugged in 6 in for x, and I multiplied it by 2 and subtracted 8, and I end up with 4. And so I end up getting f of 6 equals 4. There's my input, there's my output, telling me everything I need to know about what's happening in that function. All right, try one more with number 7. make sure you're not just writing negative 13 as your answer. It's really important when we're using function notation that we are writing the whole thing. F of negative 4 equals to negative 13. That's really part of the big purpose of it, is to see what's going in and what's coming out all in the answer. Okay, so now I'm going to ask you to make up some functions for yourself here. I'm going to ask you in this first one here, make up a function for a way to double something and then take away 4 from it. Okay, so in this particular case, I'm going to make a function. I'm going to call it f of x. Now, I'm going to take something, and I'm going to double it, which means multiply it by 2, and then take 4 away from it. There's my function. F of x, whatever I put in my input, in this case here, is going to be doubled, and then it's going to take away 4 from it, and to give me my output. So there is my function of a way to double something and then take away 4 from it. All right? Now I'm going to ask you to do this one starting from scratch. Make up a function for a way to triple something and then increase it by 7. All right, so hopefully you've got f of x equals to 3x plus 7 for that one. Now we're going to take a look at another function. This one's f of x equals to x plus 5. This is something that takes, no matter what you put into it, you're just going to add 5 to it, okay? So here's my input is the x. My rule is I'm going to add 5 to that x. And my output is whatever f of x becomes. In other words, what does it become after I add 5 to it? So for example, I put an input of negative 2. I plug a negative 2 in here. And now my rule is I take negative 2 and I add 5 to it. So there's what I write here. And my output is whatever I get when I do negative 2 plus 5, which gives me 3. All right, and I'm going to ask you to go ahead and fill the rest of this table out here. And then we can check to see how well you did on that. Okay, there's the answers. Now if we look at this table, we're going to look at a new vocabulary word, something called domain. And a domain is what are all the possible input values. In this particular case, there's actually an infinite number of input values I could put in this table, but in this case, these were the only ones that we tried as inputs. So a list of the, the domain is a list, and a list of the input values. I'm going to go ahead and write that list. And so I'm going to write in negative 2, negative 1, 0, 1, and 2. And the range here is actually a list of the output values, these values right here that we just got. And so we're going to go and make a list of those output values, which are 3, 4, 5, 6, and 7. So a new vocabulary word, the domain is what a list of all the possible inputs that you put in, and the range, all the possible output values that you get out. Usually this is x, and we can think of this as y or f of x. And that's a really interesting thing, that f of x and y are actually the same thing, which is why I was saying that you're not actually learning something new, just a different way of writing it. Okay, so here we are. Sometimes function notation is not used and 2 variables are used instead. For example, f of x equals x plus 5 is often written y equals x plus 5. You're actually used to seeing that from before. You have seen this one before. This is the new one, but it's really the same thing as something else you've seen before, as y equals x plus 5. So f of x and y are sort of interchangeable, but it's just used for a different purpose, particularly so that in the answer you can see the input and the output. That's why we like the function notation in there. So if these two things are the same, then what would be another way of writing f of x equals 2x minus 1? And sure enough, we will get y equals 2x minus 1. Same function, instead of f of x, we put in y. We don't have to use just y and x. There's any variable we want to. Number 14, the zoo needs 1.5 tons of specially mixed elephant chow to feed its elephants each week. This one says, write a function using 2 variables to represent the amount of elephant chow needed for W weeks. All right, so we have chow. We'll call this, or we could say tons of chow. We could make T. All right, and so I'm going to let T equal tons of chow. And let W equal weeks. We already know that part. All right, we're ready to write an equation. the amount of tons that we will get at any particular time here is equal to 1.5 tons for every week that we have. So there is our function. All we're doing is taking whatever our input is, the amount of weeks in here. We have our weeks as the input, and we're going to multiply, since we have 1.5 tons of chow coming out every week here, we're going to multiply that by 1.5 every time that we put that in. Okay, so using that function, how much elephant chow will the zoo need to feed its elephants for 12 weeks? Well, we're going to put in, our input is going to be 12. So we're going to go ahead and take that equation, t equals 1.5w, and instead of w, we're going to put in the number of weeks, which is 12, and then we're going to multiply 1.5 times 12, and I get 18 tons of chow. Okay. Let's look a little bit more closely at the two ways of writing the function that we've learned here. We say that we have an equation y equals 2x minus 3, and that's a function that doubles a number, there's times 2, and then takes 3 away from it, minus 3. You can also rewrite that same function as, instead of y equals 2x minus 3, f of x equals 2x minus 3. Okay, the same function, just written two different ways. Okay, so now we are going to write a function in both forms above that takes a number and triples it and then makes it 4 units bigger. So go ahead and do that. So there we have it in two different forms. All right, now looking at the equation in this one that has the y in it here, find out what y is when x is negative 3. All right, so go ahead, plug the negative 3 in for x and solve for y. And we should get the answer that y equals to negative 5. All right, now let's take a look at the equation number 1 that has f of x in it here, and find f of negative 3 of this function. Okay, so these functions, f of minus 3 equals negative 5, says the same thing that this one does, y equals minus 5, but it's much clearer because it tells you the input and the output. This one just gives you the output. We have to kind of look back at the problem to see what the input was here. This is nice about function notation that does that. All right, now I'm going to ask you to make up your own function, all right, something different than f of x equals 3x plus 4. Just make one up, put it in there, and then you're going to describe in words what it does to the function. You're going to find f of 5 and f of minus 1, and then you'll continue after you do that. And then at the end here, the last thing I want you to do, number 8 here, is for that function that you just created, these are the inputs, negative 2, 0, and x. We're plugging in for x. Show your work, what you're doing them as you plug them into your function. And then here, I want you to put the answer. What is f of minus 2? What is the output? F of 0, what's the output? F of 3, what's the output? Put that in there. All right, and that's basically it for today, except for the practice that you're going to do to get to know these concepts a little bit better.